Hello, everybody, and what is up? Welcome to another answer key video. And this one, we are going to be going over the conservation of energy practice problems. Okay, so let's jump right in and start this off with a bang, hopefully, right? So, conservation of energy practice problems. Number one, a 3 kilogram rock sits on top of a 0.8 meter ledge. If it's pushed off, how fast will it be going at the bottom? Okay, so we want to look at that. All right, so as always, with conservation of energy, we are looking at this type of equation, okay? So all of the energy total before must equal all the energy total after. When we're talking about energies, we're talking specifically about potential energy and kinetic energy. So all the potential energy before plus all the kinetic energy before must equal all the potential energy after plus all the kinetic energy after. We could break that down further. Break that down into our equations. mgh plus 1/2 mv squared equals mgh plus 1/2 mv squared. Okay, now we can finally start to look at this problem, because remember, conservation of energy says all the energy in the beginning, you're still going to have all that energy at the end. The difference is how that energy looks. Okay, is it potential? Is it kinetic? Is it chemical? Is it gravitational potential? Along all those different lines, okay? So your mixture of energy, what category it's in may be different throughout the trip from beginning to end. However, your total energy will not be different. And that's the most important thing to remember, okay? So we're really only talking about gravitational potential and kinetic. So those are the only ones we have to worry about. I'm sorry, it is like a windy storm out right now. The trees are going like crazy. We got whitecaps out on the lake. It is crazy right now. So that keeps getting my attention. I'm like, hopefully my house isn't going to blow away. So I got a little shit outside. So, but anyway, let's continue. So some of the information we have. We know the mass is 3 kg. We know the height is 0.8 meters. And we want to find how fast it will be going at the bottom. All right, let's start to fill this in. 3 times 9.8 times 0.8 meters. M, mass, G, gravitational constant, H, height. Now, it sits on top of a 0.8 meter ledge, which means it has 0 kinetic energy. It's not moving. Now, at the very bottom, what's its height? 0. You got it. So that turns this whole thing into 0. And then we fill in plus 1/2 m. The mass is still 3, and we want to find that velocity. So in this case, all the energy started off as potential, and it was transferred to only kinetic. All right, continuing to solve this, we get 23.52 equals 1.5 v squared. We need to divide by the 1.5. We get v squared as equaling 15.68. How do we undo the square? We square root it. Very good. And we get v as equaling 3.96. Oh my God, that is a horrible 9. Horrible 9. 3.96 meters per second. And there's our answer. So we just did a conservation of energy. This is all they are. All right, that's it, guys. Makes it nice and easy. Pause this now, because I'm going to erase. All right, now we are going to take you to number 2. So number 2, a physics teacher. Hey, that's me. A physics teacher exerts a force upon a 3.29 kilogram pile of snow to lift it and set it into motion. The snow leaves the shovel with a speed of 2.94 meters per second at a height of 0.562 meters. Determine the work being done on the pile of snow. Okay, this one is slightly different. And I know you're saying, well, Mr. F, why did you put it on a conservation of energy sheet? I apologize, but it's still very important to go through. Let's write down all the information we have. So we have a mass, we have 3.29 kilogram, 3.29 kgs. We have a velocity of 2.94 meters per second. We have a height of 0.562 meters. And what's happening? This pile of snow, here's the pile, here's the shovel, right? It's being lifted and then thrown. So we have two parts to this, the part to lift and then the part to throw. So there's two types of energies that are being done. We have the GPE part, and then we have the KE part. In order to find the work of each specific part, remember, work is energy, we just solve for joules. But we want to find the total work that was done on the pile of snow, which means we're going to find the work done for the GPE portion, MGH, and we're going to add it to the work done that's for the work that is done by the KE portion, 1/2 mv squared. Let's go through and do that. All right, so for the GPE portion, that is MGH, which is really 3.29 times 9.8 times a height of 0.562. Multiplying all of these out, we get 18.12 joules. Okay, it's part of it. So that 18.12 joules was the energy needed to get the snow and then lift it. And that's it. The energy that was gained, that was the work that was done. Bada bing, bada boom. Let's move on. Now for the KE, we're doing 1/2 mv squared. 1/2 the mass, 3.29 times the v squared, 2.94 squared. I'm gonna erase my shovel right here. And this comes out to be 14.22 joules. Now we found the energy that was given to the snow by throwing it, which was the work that was done to it. So let's just add these two up. And adding the two, we get 32.8 joules. And that there, folks, is the total amount of work that was done. All right, you guys are doing excellent. Let's keep on moving. And I promise you, the rest, pretty much the rest of these problems will be that PE plus KE equals PE plus KE, that traditional kind of a conservation of energy problem. All right, which reminds me, you might have a conservation of energy quiz coming up soon. Hey, little birdie told me. So, all right, let's look at number 3. A 250 gram cart starts from rest and rolls down an inclined plane from a height of 0.541 meters. Determine its speed when it's at a height of 0.127 meters above the, above the bottom. Okay, let's get some information down here. The mass is 250 grams. Whoa, Mr. F, Mr. F, Effinator, the Fabs, Fabtastic Fabianski. You gotta slow your roll there, Mr. Fabs. That's in grams. We don't want grams. We want kilograms. So we're gonna turn this into kilograms by moving the decimal over how many times? 3 times, you got it. 0.250 kilograms. All right, now our mass is safe. Let's see, we have a height. Actually a height 1, an initial height of 0.541 meters, and a final height, height 2 of 0.127 meters. And we want to find out how fast is it going. All right, so let's set up our traditional equation, right? PE plus KE equals PE plus KE. MGH, we're just going to break it down, equals plus 1/2 mv squared equals MGH plus 1/2 mv squared. Let's break it down again, or let's plug things in. 0.250 times 9.8 times the first height, 0.541 plus. Now, it starts from rest. What does that mean when it's starting from rest? Notice I'm pointing to that V. Good job. That means it's 0. Excellent, excellent. Pay very close attention to those words. Starts from rest, is stationary, is not moving. Those phrases, very important. They'll give you a lot of information. The mass does not change. 250, gravity 9.8. Now we want to know how fast it's going when it's still 0.127 meters to the ground. So we're still going to have some potential energy in there. We didn't do a 100% transfer. There's still some potential. Plus 1/2 m.250, and we're looking for the V. Please, guys, remember, I know it's kind of blurry. I apologize. Remember that square only belongs to the V. Square only belongs to the V. Doing this out, let's get us a little math in here. This is 1.33 equals 0.311 plus 0.125 V squared. First thing that we have to do is, you got it, subtract the 311. That gives us now 1.019 equals 0.125 V squared. And then we divide. You guys are doing excellent. And we get V squared as equaling, let's see, V squared as equaling 8.15. And you know my question already is going to be, how do we undo the square? And you're going to tell me, by doing the square root. Good job. We square that and we get a velocity. This car is traveling at 2.86 meters per second when it is still 0.127 meters above. So we were looking at some type of inclined plane here, right? So we were starting off, here's our inclined plane, right? The cart was right here. This is its first spot. It was just sitting there. It was not moving. It had that height of 0.541, and then we let it go, meters. And now we want to know, well, what is its velocity right here at 0.2? When it still has the height of 0.127 meters. That's what we're looking at. That's the picture, okay? That's the picture, guys. All right. So pause this if you need to, because we're erasing. So, oh man, I should have left that. Well, next time. So how's everybody doing out there in TV world? I can honestly say, when I started my whole teaching, I never thought I would be on the YouTube. And as of making this video right now, I think we got something like 63 subscribers. So I have to thank all of you guys. I am on my way to that 1 million subscribers. I think I need to get like a gold button or something. I don't think it's going to happen, but I'm being optimistic. I am being optimistic. I know as long as I push out the good educational, academic, physics, environmental science, oceanography content, I know they will subscribe, you know, right? Push it out there and they will subscribe. And one day I'll have a gold YouTube button hanging right there in my office. So yeah, really excited about that. And don't worry, I will not forget the people that put me here, and that is you, and you. All right, guys, let's keep moving on. Number 4. So here we are with number 4. And if you're new to the channel, hello, great to have you. I'm Mr. Fabianski, and this part is physics. We have a whole bunch of other playlists out there with a couple different classes and some videos such as like the doc reveal and the check-ins, mug collection. So hopefully you venture across the channel and check everything out, and yeah, hopefully have a good time doing it. So back to physics. A 4,357 kilogram roller coaster, 4,357 kilogram roller coaster starts from rest. There's that key word, rest. So its initial velocity is 0. Atop a 36.5 meter high track, 36.5 meters. Determine the speed of the car at the top of the next loop that is 10.8 meters high. So we're dealing with another height. This is very similar to the other problem where we're looking at, we have all of this energy to start with, and then we're going to see what does the velocity become when we still have a little bit of potential and some kinetic. So again, our conservation of energy, right? PE plus KE equals PE plus KE, mgh plus 1/2 mv squared equals mgh plus 1/2 mv squared. The mass 4,357 times g 9.8 times a height of 36.5. That is the initial height. It said it was from rest, starting from rest, which means velocity is 0, which means that whole thing cancels out, equals. Now, we do have, if we're looking at, here's, right, is it a loop or a hill? It is a loop, right? So we started here at this point. Now we're looking here. Notice, we still have some height. So there's still some gravitational potential energy, but it's moving now, right? So there's kinetic as well. And we're looking specifically for the velocity component of that kinetic. But we know we still have gravitational, so we still need to plug it in. All right, let's see. So mass, we got that. 4,357 times 9.8 times the new height of 10.8 plus 1/2 the mass 4,357 times the velocity again. I'm going to get these numbers. These are some pretty big numbers. So we got 1,558,498.9 equals 4,61144.88 plus 2178.5 v squared. We need to subtract this over first. And for this, we get 1097354.02. I know these numbers are cumbersome. I apologize. Equals 2178.5 v squared. We divide by the 2178.5, and we get a v squared that's equaling 503.72. We square root that to get rid of the square, and we get a velocity of 22.4 meters per second. And that is how fast the roller coaster is going at the beginning or at the top of the next loop. So hopefully this has helped you guys. This was only questions 1 through 4. I'm going to come back with another video so we can go through 5, 6, 7, and 8. But I want to give you some time to digest this. I will link that video up right here, right in the middle, right there. There it is. Click on it, and that'll take you through 5, 6, 7, and 8. Everybody have a great day, and I will see you in the next video. Mr. F saying, be cool, man. Do your physics. Bye, everybody.